Hi guys. Okay, we wanted to finish off this lesson. Now, we got halfway through it or so. I might as well just start at the beginning for anyone that was missing for the first aid or what have you. So I'll just start at the beginning. So anyway, we've got some definitions up here that you can read through. The domain, we're going to talk about all the possible set of x values. The range is a set of all possible y values. And we've done this. We did this yesterday. We talked quite a bit about this, so we're going to start off and just start looking at this. Now, it's getting harder. I'm going to give you this, and I'm going to say, state the domain and range for each of the following. Well, they didn't give you a graph for this one. This one's definitely more challenging. Hopefully you remember from grade 10, and if you don't remember, you're going to have to look it up pretty quickly. But for this question, we're looking at a vertex of 3, 5. If you don't know how to do that, you're going to have to come and get some help or figure that out, but this is in vertex form. That's the H, that's the K, and off we go. You're also going to notice that it's negative here, so that means that this parabola opens down. So we have that information. What that would mean is that if I was to get a quick sketch of this parabola, you would notice that it would go over to 3 and up to about 5. That would be its vertex, and it would be opening down. And it would continue to go down and down and down, and it's going to continue to get wider and wider as it goes down, and we have enough information now to figure out the domain and range. So the domain of this function is going to be the set of all x such that x is an element of the real numbers. You can tell that because as it continues to go out this way, it continues to go out this way, which means that all the values of x on the x-axis are going to have a corresponding point on the curve. So each of these values on the curve have the values of x for its domain. Looking at the range, you'll notice that the range, however, has a highest point it can get to. The highest value y can be is 5. So your range is going to be the set of all y such that y must be less than or equal to 5 and y is an element of the real numbers. So again, that's working off of what we did last day, and it should be fairly straightforward. Here's my happy face. Notice that these are all distinct points, so the domain is going to have to look a little bit different. It's not going to be the set of all x element of the reals or a whole bunch of numbers. It's just these distinct values. So my domain is going to be -3, -2, so I have a value there, a value there. I don't have one for -1, 0, I don't have one for 1, 2, and 3. The range is going to go down to -3. I have one at -2. In fact, there's 2 of them. I have 3 of them that are at 0. And I have, it looks like, 2 of them at 3. Okay, so that was looking at the y values. Now, this is something new to it, something that you haven't seen before. So I've got a horizontal line here that's going to come out like this. And I've got a vertical line here that's going to come up like this. Now these lines, I'm going to tell you, are at y equals -1. And this vertical line is at x equals -4. And what's happening is that this curve, now I don't have arrows on the curve, but that's because of my printer program, but what that's trying to show is that your curve is getting closer and closer and closer to these horizontal lines, but not touching. It's getting closer and closer and closer and closer, but just miss it. And that's a concept that we started talking about earlier. It sort of hurts your head a little bit, but if you think about the domain and range here, that all these x values are part of the function, all the way up to except -4. And all these values of the curve have x values on the x-axis except for -4. So your domain is all the values of x except -4 such that x is an element of the real numbers. Now something I should really make clear here is that this function has 2 parts to it. There's this part and there's this part. And they're not connected. They're not connected at all, but they're the same function. It's the first time you've seen that, okay? They're not connected, but it is all one function. You need both parts to be able to have that function. Let's take a look here. Range, you'll notice that all your y values have a place. All your y values have a place except for that horizontal tangent. Or sorry, not tangent, except for that asymptote. Y such that y cannot equal -1, and y is an element of the real numbers. Now these, brace bracket. Now these lines have a special name and they're called asymptotes. I better learn how to spell it. There we go. Asymptotes. And this is an asymptote, so I got an asymptote there, and I got an asymptote there. And the definition of an asymptote is a line, the curve approaches but never touches. And that's a new concept, so we're going to have to think about that a little bit more today, and we've got a little bit more questions that we can do for that. So let's flip over to the second side. So we're going to have a bit of a discussion about asymptotes. A horizontal asymptote is a horizontal line that a curve approaches, but never touches or crosses. A vertical asymptote is a vertical line that the curve approaches, but never ever touches. Now notice they got a little bit more technical here. A vertical line is a line that the curve approaches both from the right-hand side of the vertical line and the left-hand side. Let's make sure everyone knows what I'm talking about here. Here is your asymptote. Okay. I'm going to tell you that that's at the point y equals -4, or sorry, x equals -4. Okay, so it's a vertical line. And you'll notice that your curve is this guy. Okay. And your curve is this guy. Two pieces, not connected. You have to deal with that, okay? So there's your curve. Now notice that your curve approaches this vertical asymptote in both directions. It approaches from the right and it approaches it from the left. Now when we approach from the right, what we say is x approaches -4 from the right, and that means from the right. So values that are greater than -4. From the right side of -4. And when I approach this way, so I'm approaching -4 but from values low, on the left-hand side of -4, we say x approaches -4 from the left. And that little negative up there means from the left side of -4. Okay, so you're coming at it from the two directions. The sun's getting pretty bright. I'll just close the blinds here so you don't have so much glare. All right. So there you go. So now we can talk a little bit about what happens as that function approaches x, as x approaches -4 from the right. You'll notice that the function is taking off to positive infinity. And over here you'll see that the function is taking off to negative infinity. So that's for a vertical asymptote. Now for a horizontal asymptote, what happens is that the curve approaches from above or below. Now here's a horizontal asymptote right here. Now I'm going to tell you that that value is, I'm going to say 3. So I'm going to say that that is the horizontal line y equals 3. Your curve is here and here. Notice they're not connected, but it's both part of one curve. Now, there's also a vertical asymptote here. I'm just not talking about it right now. I'm just talking about the horizontal asymptote. There's also a horizontal asymptote here. I'm just not talking about it. I'm going to talk about horizontal asymptotes over on this side. Notice that the horizontal asymptote happens as x approaches positive infinity. So my horizontal asymptote is as x approaches positive infinity, the y-axis is approaching 3 from above. That's a horizontal asymptote. And over here, as x approaches negative infinity, you'll see that the curve is approaching y equals 3 from below. and when we mean below that line. So here's a vertical asymptote, and this one is a horizontal asymptote. Notice that they both have asymptotes. I just don't want to write so much on here so it gets ugly. This is an exponential function, and an exponential function has an asymptote. They have a horizontal asymptote. It's right here for this particular function. Well, I'm going to say that it is at y equals 3 as well. And you'll notice what happens here, that it's a horizontal asymptote only in one direction. Okay, so the curve is only approaching the horizontal asymptote as x approaches positive infinity. So as x approaches positive infinity, you'll know that the y is actually approaching 3. Over here, that's not happening, okay? Certainly not a horizontal asymptote. If we wanted to talk about end behavior, what's happening out here for the curve, you'd say as x approaches negative infinity, y is approaching positive infinity. So as x is getting larger and larger negatively, y is getting larger and larger positively. That's called end behavior. This is called behavior for an asymptote, behavior for a horizontal asymptote, behavior for the vertical asymptote. Once again, not really much there to say. We'll just leave that alone, and we'll take a look at some more questions. Some discussions on end behavior. So I started to talk to you about end behavior, and let's see what this has to say. As x approaches the vertical asymptote from the left, y will approach either positive infinity or negative infinity. Well, that kind of makes sense if you think about it. Both of these are saying the same thing, and as x approaches a vertical asymptote to the right, it's either got to approach positive infinity or negative infinity. That kind of makes an awful lot of sense if you think about it. Here is a asymptote, bump, 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 bump. It's a vertical asymptote, okay, which means that your curve can come up and approach that, and it's got one of two choices. It's either going to go up that way, or it's going to come and go that way. It can't do both and be a function. Okay, it's got to choose one or the other, but that's what's got to happen. So as it approaches the vertical asymptote to the left, from the right, sorry, so I'm approaching it from the right, I got to either go up to positive infinity or down to negative infinity. Same's going to happen as I approach this way. As my function's coming at it this way, I've either got to take off down this way, or I've got to take off up that way. I don't get to choose. And that's pretty much the case in grade 11 for asymptotes. However, in grade 12, we'll talk a little bit about asymptotes in a different light. Now, what happens here? As x approaches negative infinity, y will approach a horizontal asymptote from above or below. And as x approaches positive infinity, we're going to approach a horizontal asymptote either from above or below. So again, we've sort of looked at that already, but we can look at it again. For this one, let's talk about its horizontal asymptote. So its horizontal asymptote is here. It's at the y equals 3. So notice that your function, your actual function is this guy. Okay, so arrows on the end. Remember, my computer program doesn't do the arrows very nicely. And there's another part to this function. It's down here. Now, they're not connected, but they're still the same function. There's two parts to this puppy. So there's my function, and there's my horizontal asymptote. So if we want to talk about behavior, what we would say is something around the lines of, as x approaches positive infinity, your function y is approaching 3 from above. And over here, as x approaches negative infinity, so as x gets larger and larger and larger, your y value is approaching 3, but from below, because you're below the line. You're below the asymptote there. Now, if you take a look at the vertical asymptote is here, okay, and it's at x equals 2. So if we want to talk about the behavior as we approach that, perhaps using a different color, I would say as x approaches 2 from the right, so I'm on the right-hand side of 2, in other words, I'm getting values that are larger than 2, I would say that y is approaching positive infinity, and as I go this way, I would say x is approaching 2 from the left, so values that are less than 2, the y is approaching negative infinity. And that's how we would talk about that. So this is called behavior for the horizontal asymptotes, and this is the behavior for the vertical asymptotes. find a cute little example over here. We got a cute little parabola. Doesn't show up so great. Let's put a little bit of orange on it. Maybe it'll look better. And we're going to remember that there's supposed to be arrows there. No asymptotes. None. Okay, just end behavior. What's happening here is that as x approaches positive infinity, you'll notice that y keeps getting bigger and bigger and bigger, so it's approaching positive infinity. And as x approaches negative infinity this way, you notice that y is also approaching positive infinity. So that's called end behavior. No asymptote. This is asymptotic behavior, so as it behaves close to the asymptotes, this is called end behavior. And that's what's happening at the ends of the curve. As x goes to its extremes, positive infinity keeps going this way, negative infinity keeps going this way. So end behavior. And this is behavior near the asymptotes. And so you've got some things happening here. I don't really like this example, to be honest with you. It doesn't show things really the way I'd like them to be shown. Here's your curve, and this is another part of your curve. Okay, and you'll see that you've got a vertical asymptote here, so as it approaches the vertical asymptote from the right, it's going to infinity. As it approaches from the left, it's going to infinity. That's what they're trying to show here. So I would say as x is approaching 2 from the right, y is approaching positive infinity. As x is approaching 2 from the left, y is approaching positive infinity. Okay, so they can both go to positive infinity if you want. Down here, you've got the limit, not limit, sorry, that's calculus. As x is approaching positive infinity, you've got y is approaching, coming down closer and closer and closer to 0. And this one, I don't know what's happening here. I don't know if they mean for this to be coming back up or if it's just going straight out here. Let's assume that as x approaches negative infinity, it's approaching this value in here. Let's call it 1 or 1/2 even. That would be 1 1/2. It seems that y is approaching negative 1/2, and I would say from above. So I'm assuming that there is a horizontal asymptote for this guy right there, which is different than the horizontal asymptote that this one's approaching. All right, so good enough with that. We'll flip. And this is your homework. Let's see that. So, good, good, good. There's your homework. Very cool. So I wonder why I didn't finish this in class. There you go. So what you're going to do is you're going to describe each of the following functions based on its domain, range, and asymptotes, if any. So remember that all of these have arrows on the end, please. So these functions, okay, all of these have arrows. Can you see what I'm doing? I'm putting arrows on them. Notice there's no asymptotes here, so don't get too upset. Notice that there is a horizontal asymptote here. There's a horizontal asymptote here. They haven't shown it, but there's a vertical asymptote here. And let's call that at x equals 3, and we'll call this one at y equals 1. So you can go through this. Let's look at this side. Let's make these a little bit better. So we're going to put a little arrow there, a little arrow there, a little arrow there, a little arrow there. Notice that there's a horizontal asymptote that's missing here. It should be right here. Not a horizontal, sorry, a vertical asymptote. So there's your vertical asymptote. There's your horizontal asymptote. Over here, you've got your horizontal asymptote here. Notice that your curve is still going. Now, it looks like it's touching here, but it's not. Miracle of math, we know that it's not. And over here, now look, this is what we call a restricted domain. X must be greater than or equal to 1. So that's going to be a dot. It's equal to, so it's a solid dot. It must be greater than 1, and it can keep going. And this one over here is going to have an arrow here, 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 and an arrow here. And these are all parts of the same function. So that, and that are all the same function. And you're supposed to be able to see some asymptotes here. So there's a vertical asymptote here, there's a vertical asymptote here, and there's a horizontal asymptote here. So what you're going to do is go through all those, and you're going to discuss them in terms of domain and range and end behavior, and all of your answers are here and here. Okay? All right, guys, I'm going to leave that with you and finish this up, and we'll move on from there.